Good day everyone! This is Teacher Leo and welcome to Analytical Chemistry subject. On this video, let's talk about expressing concentration of solutions and preparation of solutions. On this video, we are expecting that you can accomplish the following tasks with 75% proficiency. First, you can define concentration of solutions. Second, discuss the different units used to express the concentration of a solution. And last, you can demonstrate how to prepare solutions. Have you ever wondered what a solution is all about? Yes, solution is equal to the solvent plus the solute. Have you already cooked a salty soup? It becomes salty because it has more salt than water, or it has more solute than the solvent. It is more concentrated. Concentration of solutions has many ways to express. We have here the concentration in parts per million, mass percentage, volume percentage, mass by volume percentage, molarity, molarity, normality, formality, and mole fraction. Let's have our activity entitled Arrange Me. On this activity, you are going to arrange the jumbled letters to form the correct word. Let's have first number 1. So what is this word? Alright, so correct. That is concentration. Concentration is the amount of solute present in 1 liter of solution. It is denoted by C or S. C or S is equal to weight of solute in grams and divided by the volume of liters. So concentration in parts per million or ppm. So the parts of a component per million parts or 10 raised to the power of 6 of the solution. So it is ppm or parts per million is equal to total mass of A or the solute divided by the total mass of the solution and multiplied by 10 raised to the power of 6 or that is million or 1 million. It states that our problem, an aqueous solution has 0.0090 grams of oxygen dissolved in 1000 grams of water. So calculate the dissolved oxygen concentration in this solution in parts per million. So by using our formula in getting the concentration in parts per million, we have here mass of solute divided by the total mass of solution times 10 raised to the power of positive 6 or that is 1 million. So ppm, substitute all the given values. We have here the given solute that is equal to 0.0090 grams and the total mass of the solution, as we all know that solution is equal to the solute plus the solvent. So our solute here is 0.0090 grams plus our solvent that is 1000 grams. In times 110 raised to the power of 6 or 1 million, our ppm or parts per million is equal to 8.99. Number 2. What is this word? Okay, so that is mass percentage. When the concentration is expressed as the percent of one component in the solution by mass, it is called mass percentage. Suppose we have solution containing component A as the solute and B as the solvent. Then it is the mass percentage is expressed as mass percentage of A or is of the solute is equal to mass of component A in the solution divided by the total mass of the solution times 100. So that is the mass percentage. States that a saline solution with a mass of 390 grams has 40 grams of sodium chloride dissolved in it. What is the mass percent concentration of the solution? So by using our equation, the formula that is mass percent or mass percentage is equal to the mass of component A in the solution, or that is our solute, divided by the total mass of the solution times 100. Now, we have the solute of 40 grams and our total mass of solution that is 390 is times 100, that is equal to 10.25%, that is our mass percentage. Number 3. What is this word? Alright, so that is volume percentage. Sometimes we can express the concentration as a percent of one component in the solution by volume. It is then called as volume percentage and is given as volume percentage of a solute is equal to volume of component of the solute in the solution divided by the total component of the solution times 100. That determine the volume percentage of solution made by combining 50 ml of ethanol with enough water to produce 250 ml of the solution. So in order to get our volume percentage, let's use our equation. It says that volume percentage is equal to the mass of component A in the solution, or that is our solute again, divided by the total component of the solution. So that is the total component times 100. Substitute all the given values. We have our solute of 50 ml of ethanol, or that is 50 gram. ml and gram is just the same or equal, and our 250 ml. So that is the volume. That is our solution. Solution is equal to solute plus solvent. So our solvent here is 250 and our solute is 50. 250 plus 50 is equal to 300. 50 divided by 300 times 100 is equal to our volume percentage is equal to 16.67%. 4. What is this word? Alright, so that is mass by volume percentage. This unit is majorly used in the pharmaceutical industry. It is defined as the mass of a solute dissolved per 100 ml of the solution. Volume percentage states that calculate the mass per volume percent of a 876.9 milliliter solution that is prepared by dissolving 323.16 grams of calcium acid in water. So, in order to get the mass per volume percentage, we are going to divide the mass of solute divided by the volume of solution times 100. So, substitute all the given values. That is, our mass of solute is equal to 323.16 grams divided by 876.9 milliliter. So, from mass and volume times 100. So, it's 323.16 divided by 876.9 times 100 is equal to 36.85%. That is our mass volume percentage. 5. What is this word? Okay, so that is molarity. One of the most common used method for expressing the concentration in molarity. It is the number of moles of solute dissolved in 1 liter of a solution. Suppose a solution of ethanol is marked 0.25 moles. This means that it is 1 liter of the given solution of 0.25 moles of ethanol is dissolved. Here states that seawater contains roughly 28 grams of sodium chloride per liter. What is the molarity of sodium chloride in seawater? By using our equation or formula, that is molarity multiplied by the volume is equal to the grams of solute divided by the molar mass of solute. So, we have our M, or the molarity, that is the missing one. So, let's denote it as X. And substitute the volume, that is 1 liter or per liter. So, our solute here is 28 grams of sodium chloride. And its molar, or a molar mass of sodium chloride, or our solute, is 58.443 grams per mole. So, 28 divided by 58.443 is equal to 0.497. So, in order to cancel out 1 liter, in order to find the molarity, let's divide both sides by 1 liter. So, it's just the same. 0.497 divided by 1 liter is equal to 0.497 M, or that is our molarity. Sixth, what is this word? Alright, so that is molality. Molality represents the concentration regarding moles of solute and the mass of solvent. It is given by moles of solute dissolved per kilogram of the solvent. The molality formula is given as molality, or small letter m, is equal to the moles of solute divided by the mass of the solvent in kilogram. The problem here states that a sulfuric acid solution containing 571.4 grams of H2SO4 per liter of solution has a density of 1.329 grams per cubic centimeter. Our problem here is to calculate the molality of H2SO4 in this solution. In order to find the molality, let's use its equation, that is M, or molality, small letter m, is equal to moles of the solute divided by the mass of the solvent. Now, as we all know that 1.39 grams per cubic centimeter, we are going to multiply that by the 1000 cubic centimeter. So where we have, or where we got the 1000 centimeter, I mean 1000 cubic centimeter, that is from the solution or the solvent. You see that per liter, so as we all know, in 1 liter there is 1000 cubic centimeter. Alright, so that is equal to 1329 grams. So 1329 grams minus 571.4 grams, that is equal to 757.6, or that is grams, 757.6 grams, and it's converted into kilogram. So let's divide it by 1000, so that is equal to 0.7576 kilograms. Now the next step is to divide 5.826 mole divided by 0.7576 kilogram. So that is equal to 7.690 molality. So that is our molality in H2SO4 in this solution. 7. What is this word? Okay, so that is normality. It is the number of gram equivalents of solute present in 1 liter of the solution, and it is denoted by N. Normality, or capital N, is equal to the weight of solute in grams divided by the equivalent mass multiplied by volume in liters. 8. What is this word? Alright, so that is formality. It is the number of gram formula present in 1 liter of solution. It is denoted by F. F for formality is equal to weight of the solute in grams divided by the formula weight times volume in liter. It is applicable in the case of ionic solid like sodium chloride. And last, what is this word? Okay, so that is mole fraction. If the solution has a solvent and the solute, a mole fraction gives a concentration as the ratio of moles of one component to the total moles present in the solution. It is denoted by X. Suppose we have a solution containing as a solute and B as the solvent. Let Na and Nb be the number of moles, and A and B present in the solution respectively. So mole fractions of A and B are given as XA is equal to Na divided by Na plus Nb, or the mole fraction of Xb is equal to Nb divided by Na plus Nb. Alright, so those are methods that are commonly used ways to express the concentration of solutions. Different units are used to express the concentration of a solution depending on the application. So the concentration of a solution is the quantity of solute in a given quantity of solution. So it can be expressed in several ways, like molarity, or the moles of solute per liter of the solution. The mole fraction, that is the ratio of the number of moles of solution to the total number of moles of substance present. The mass percentage is the ratio of the mass of the solute to the mass of the solution times 100. The parts per thousand, or PPT, that is grams of solute per kilogram of solution. And parts per million, that is ppm, is the milligram of the solute per kilogram of the solution. And the parts per billion, that is the microgram of solute per kilogram of solution. And the molality is the number of moles of solute per kilogram of the solvent. And now, let's move on to preparing stock solutions. Solutions are commonly made up in the laboratory from solid materials, from liquid, or from other solutions. The description assumed knowledge of the calculations required to determine the solution concentrations, the ability to accurately weigh solids, and pipette liquids. From solid materials, first, you are going to determine the concentration and the amount of solution required for the experiment. Second, calculate the amount of solute required to prepare the desired solution. Third, weigh out the amount of solute calculated in step 2 and obtain a volumetric flask of appropriate volume. Next, add the solute to the volumetric flask. Fill the volumetric flask approximately 2/3 full, stopper, and mix. Do this by inverting the flask, shaking and returning the flask to upright. Do this 10 times. Make sure to hold the stopper in the flask. Next, carefully fill the flask to the marked edge on the neck of the flask. Use a wash bottle or medicine dropper if necessary. And last, mix the solution thoroughly by stoppering the flask securely and inverting it 10 to 12 times. Preparing the solution from liquid to other solution. So first step, you are going to determine the concentration and amount of solution required for the experiment. Next, calculate the amount of stock solution or liquid required to prepare the desired solution, or that is, a stock solution is one with a known concentration greater than the solution you are preparing. Next, use a pipette to measure the amount of solution or liquid calculated in step 2. Next, add the solution or liquid to a volumetric flask of appropriate volume. Then, fill the volumetric flask approximately to 2/3 full and mix. Next, carefully fill the flask to the mark etched on the neck of the flask. Use a wash bottle or medicine dropper if necessary. And last, you are going to mix the solution thoroughly by stopping the flask securely and inverting it 10 to 12 times. Alright, so I hope you learned a lot from this video lesson. Thank you for watching, everyone.